Hi everyone, and welcome to our webinar. I'm Diego. I'm the community manager at Cloud Academy, and today we are really proud to have with us Nik Graf from the Serverless family. He will present an amazing session on serverless and GraphQL, a love story. Nik, how are you today?
Pretty good. It's early in the morning in San Francisco, but that's fine. I get up usually at 7, so right now it's 8, so that's a perfect fit.
All right. So I want to quickly remember some notes. So if you guys have questions during Nik's presentation, you can post it here on the chat, and we'll make sure to answer all your questions in a final Q&A session. And you can also post in our community forum at cloudacademy.com/community, and we'll be happy to answer all the doubts that you guys have. So Nik, it's all yours.
Awesome. Okay. So hello everybody. Thanks for joining. What I'm gonna do is today is I'm gonna first introduce you. So there's people probably coming from both sides, like people who know GraphQL already. So I'm gonna introduce serverless for them, and there's probably people who have heard of serverless. So I'm gonna do an introduction for GraphQL as well. So I'm gonna introduce both topics, and then eventually show like why they are such a good fit together. And show you the benefits, show you some lessons learned, and yeah, so let's kick it off. So what I want to do first is actually go into the problem why GraphQL is an interesting technology, and to explain the problem, we're going to use the Star Wars API. You can see it by yourself. It's under swappy.co, and it's a REST API. So let's actually go there, then you can see it for a bit. So here you can go there and you can see, okay, I can actually fetch people and I get results back. So I could say, what if I want to do planets free, and I can do the request and I get a different planet. So what's happening here is, let's say we want to fetch a person that we already saw. That's pretty straightforward, and that's pretty amazing because you get back a result. And then you get a lot of stuff. You get basically all the attributes that a person has. But what if you want to do, like in a real world case, you probably don't want to just show this person, but you want to do very specific things. Like you have a few where you say you want to show this person and you want to show all the titles of the films this person has been in. And what's happening here is that like we get this relation back, and this is pretty cool because we get from Luke Skywalker, we know that he has played in the films 1, 2, 3. And but the problem here is that we don't have that information for the film. So what we have to do then, again, we have to go and fetch for each of these films. We have to do for each of them another request and fetch just to get the name. And that's a lot of fetching because we are like overfetching a lot. Like we get a lot of data here that we don't need for this specific view. We get the vehicles, we get the starships, all the relations that we actually don't need for a specific view. So it's kind of like a little bit like an apple. You're like constantly overfetching, and there's this bloated space. There's all this black stuff here. But we're on the other side, like if you do only this one request, we're missing out on the essential pieces, the names of the movies. And you have this in the real world case. You have this a lot. I've been a full stack developer, I've developed full stack, so I know both sides, backend and frontend. And as someone coming from the backend, the REST APIs, I think it's super clean, it's super solid. You know exactly what you do, you know what you can ship. It's very straightforward. But as someone working on the front end, this is often a horror because you have to fetch a lot of data. You do a lot of network round trips, and especially on mobile connections, round trips are expensive. And this is exactly the problem that Facebook, when they started to develop GraphQL, that's the problem they wanted to solve. There's like, can we actually fetch more data in one go? And because in a specific view, you don't want to, I mean, it depends. Like sometimes you want to show the name up front and then fetch the other data, but often you just actually want to show the whole view only when all the data is in there. So what are the approaches that people do nowadays, and I did a lot in the past? There's like, obviously you can extend your API. So you can say like, you can make a special API, you can make special API endpoints that are targeted for specific views. And then you build things like API/persons with films, and then you pass in the person ID. That's really neat for our front-end people on one side, because they get actually what they want, and this is pretty cool. But it's really bad for the backend people, because they start to build a lot of API endpoints and they might change quickly, because if the demand of the product, like if somebody figures out like, hey, we not only want to show the film's name, but we also want to show, or you want to show something else on that page, like not only film's name, but also like the director of that film again. You build up this complex APIs, which would be basically like persons with films with directors, and this is kind of tedious. So another solution is to stick to a REST API, but allow for query parameters, because these query parameters allow you to filter and get more relevant stuff that is needed for you. The problem here is that like you start again to like, either you make it in a very generic way that people can include all the things, or you start to build for specific cases again, and this makes you if you're not working on both sides by yourself, if you actually split by like, hey, there's someone working on the front end and someone on the back end, the feedback loop or the iteration cycle becomes really, really slow. And yeah, it gets deeper and deeper. So, but there's even like, to highlight that is, you have even, it gets even trickier when you have multiple applications, because then you have, if you have a web application and you have a mobile application, and you might have an Arduino client, depending on what you build, like they all have specific needs, they need different data, and then it becomes quite complex. And REST is, the REST concept it's really, really great because it's structured really well, but you lock yourself into a slower feedback cycle. At least that's from my perspective. And in addition to that, it gets even harder when you have multiple versions, because you cannot simply deprecate. If you still support an old mobile version and a version of your old app, then you cannot simply deprecate endpoints, and you end up building more and more and more. So complexity and code depth gets kind of out of control, and this is what happened at Facebook. And so a couple of years back, there was this team of 3 people. It was Dan Schaefer, Nik Graf, and Lee Byron, and they started to work on how to solve that problem. And the result of that was GraphQL. So that's like the introduction, like why we need GraphQL, why is it there? And what GraphQL is basically, so it has nothing to do with a graph database, or it has nothing to do with how you it's not in a sense like anything like a backend technology that gives you the graph. It's basically the transport layer. It's the connection between the front end and the backend. Obviously, you could use it in the backend as well, just to communicate. But I think that's not the main purpose. So that's we might in the near future see things that go in that route. But for now, I think the most common use case, and that's what we use it for, is this case where you actually fetch data. So what you can do with GraphQL is you can fetch data based on your needs. So let me show this example. This is graphical. This is a user interface based by the built by the Facebook team initially, and now maintained by a larger community. And it allows you basically to construct GraphQL queries, and then by hitting play, send them to get the result. You can see this under GraphQL.org, the swappy/GraphQL API. And what they simply did is they wrapped the Star Wars API. So what you can see here is on the left, to get a little bit, let's simplify this. Actually, we'll increase the screen. I hope that helps you also to see. Not much I can do that. Let's take it over to here. Can we increase here the font size? Yes, that works better. So what you can see here, let's simplify a bit, is if I have, it basically maps the keys to the results. So when I fetch a person and I fetch the person's name, then I only get back that result. And what I can do then is, I can fetch more stuff. So I can say, okay, what's the eye color of that person? And you see, we don't need semicolons here, but we can have them. So I can have, it's a very syntax to be very concise, so you can actually minimize the most out of it. What you can see here is I can actually fetch them stuff that like attributes that I really want to have. And how you build it up is like you build this graph of the connection of like how your data in the backend is related, and obviously that has to happen in the backend. But once you have done that, you can actually fetch all the stuff you want and fetch it on a basis that that your people in the front end or your people that built the mobile application, they can actually fetch the data that they need. One thing about GraphQL, it's a really handy tool because, oh yeah, let's, first of all, I copied out this connection. So somebody in the backend built up this connection, like I'm gonna show you in a bit how it looks like. Build the connection between the person and the film connection, and then you can fetch from these films that that the person Luke Skywalker has. You can actually fetch the title, and then you get back this result. And this is really handy because as someone working on the front end, you can iterate quickly on like how should UI look like, what should be in there and what should not. And if you do control space in this editor, you get an autocomplete of all the possible connections that you can see there. So you can actually do things like you can go really deep. And you can see like from all the planets here, this is the edges and nodes. Don't worry about that too much. That's because there's one client built by Facebook which is called Relay, and that's why they have this here. I think we could do planets as well, but let's not get bothered about this. But what you could do is you could see for all the, you can go really deep. So for all the films, I could even fetch like all the planets that are related to these films. All right, and that's pretty cool because you can see always on the left side, it matches exactly the key on the right side. And that's how you know how your data is structured. So let's move on. So GraphQL basically is a data querying language. The great parts about GraphQL is it's a spec, and it's not necessarily connected to any programming language. So it's like you can write GraphQL endpoints on, and you can write GraphQL clients in any kind of language that you prefer. And there's a lot of like languages out there. There's Scala implementations, there's Ruby implementations, there's JavaScript implementation, which was the reference implementation. So you can use any kind of language. In addition to that, GraphQL is backed by schema. So what you need to do is, what you can't have is, or what you must have is like, you must define how your data is connected and structured. And this gives you if you do that, this gives you a lot of benefits, because you actually figure out like how it is connected and you define it. And this is the way how we can actually then fetch these connections and get the important data out that we want. It's based on a type system. So everything, every attribute, every object, every connection is typed, which means like if you have an attribute like the eye color or the name, I have to define like, is it a string, is it a number, what is it? The benefit here is that we can do, I mean, I'm a big fan of type systems, and it gives you safety. That's really, really great. And there's even tools if you use TypeScript or flow type. I'm not sure for flow type, but I'm confident there is, and at least know like if you have a GraphQL schema, you can export your flow types out of it and use this in your front end or in your client as well to actually have some type checking if you use it in a proper way. And what's also great is that you can do full introspection. What this means is, full introspection means that you can actually look into the schema. So because you defined the schema and everything is typed, you can have you can look into the schema and see what exactly the schema looks like. I will show you an example in a bit. All right, so rewind a little bit on like how the structure looks like. So if you look at the GraphQL server, you have the GraphQL queries and on top of it, this is like how it comes in. But and then you have the type definitions. You have your application logic, that's your code. And then GraphQL doesn't necessarily also prescribe you to any way of how you fetch your data. You can build a GraphQL endpoint and you can fetch from a database directly. You can build a GraphQL endpoint, you can wrap a REST API. You could have static data in there. It's completely irrelevant. In fact, if you look at the graphical interface and if you look at the network requests, if we hit a query here and if we fetch data, so there is this REST API that is there, but we don't see any network request because what they did is they shipped the whole data set with your front end in this case, and so it's actually it's not making a request, but it's still a GraphQL query. And if you would replace that data source to have an actual remote API, the SWAPI API, which was it in the past, this application, then you will actually hit the SWAPI API. So the data source, where it's coming from, is also like, it's not described in GraphQL. All right. So what we actually do is, what happens is the server publishes, by having the schema and having the types exposed, like the server publishes the possibilities that you can do. And the client then can use this to describe like what are the specific data that I want to have and fetch exactly only what's needed. And you can, obviously, you can, if you want to do things like, I only want to fetch the person's name first, then you could do in your code, you could only fetch that person's name. And then in a second query, depending on how you would load it, you could fetch everything like everything else that you need, like for example the film connections. So you're still very flexible, but the client has the power to fetch what the client wants. And yeah, a schema basically is this arbitrary nested hierarchy of type definitions, objects with scalar types like strings and booleans or numbers, but it's not, yeah. So let's look at a schema. We have this GraphQL schema definition, and one thing that's important for GraphQL, by the definition, the root of a GraphQL schema has currently two types, which is query or mutation. So they split the whole design into these two parts, and there's going to be, like right now in progress or as a proposal, is we have a third type, which is a subscription. So if you're interested to that, I highly recommend you to see the pull request to the spec, where people are currently discussing like how subscriptions would look like. But for now, it's only the query and the mutation. So the query is only there to fetch data, and the mutation is to mutate data, but you also could receive data based on that. Yeah, and in this case, like, so we have a query, we have in our root, we can fetch our person. You can see like this is, so in the query we have that person and there's other things, but if we look at our Star Wars example, we can see these are all the roots in the query, and we can fetch different things. So I could say all the planets, and then from all the planets give me the name. So you could see like I could fetch all the planets that I want. I think it has ID as well. Yeah, so this is probably the more interesting. So you can actually do something, and you could take this to fetch another planet. But if you look at the schema, is we have these root queries, and with them you can fetch certain things. And here in this root, we referencing to another type, which is person. And there you see where the structure is coming in, where the nesting is coming in. And see, like this person has a name, has a gender, has a height, and there you also have to define the types. And then you can see also the film connection. So in our case, it's film connection, but in this case, it would be films. And then you're referencing another type. And this is how you basically build up your tree of like how, from a root perspective, your data would be constructed. Yeah. And then if you want to code, like how, the question is like, how do we fetch data now? There's like currently there are two ways. This is, I mentioned you can do this in any language. I'm going to use the JavaScript implementation. But even there's like currently there are two ways of doing things. So this is the old one, which I still use and kind of prefer. But since recently there's a new one using where you could say build schema. So basically you build your schema and you have your type, and then you have the resolver functions to actually resolve that data. You build it up as a different object, and then you can combine these both. And then you could simply query that the data by running GraphQL. You have to provide the schema, you provide the query. So let's say this is how a query looks like, hello, and then you pass in the resolvers, and then you get the actual response. What I still use is, that's what was there first, and I'm quite comfortable with it, is that you build your schema up in JavaScript instead of like writing the schema manually. So this, there you can see in GraphQL object type, and then you can from this you can export a schema. And in this case, what's happening here is if you look at like the root schema, the root query here, we define like what can be fetched, a person, for example, and then you define like the type is the person type. You pass in like what kind of arguments are accepted In this case, it would be an integer, but it's also important that it's not null. So it can't be null, so it will fail. If you don't provide an ID, it will fail. Then you get the resolver. And this is the interesting part, is because every time, I mean, in this case, it would be here. In this example, it's here. This is where I actually fetch the data. So at any point in the tree, for any attribute or any object, I can manually define like how it should be resolved. So if you have already an API endpoint to fetch all the people with all the films, then you can use this. But if you have only an internal API endpoint which fetches the person and then fetches the films, you could say for the person, inside the person type, you can make a resolver for films that it should fetch the films. And then based on the query, it will call the right resolver functions. And that's exactly the same case for here, because you can say like how these resolvers look like, and then you can match them directly to that root and build basically up like how it should be resolved. And by doing this, you basically give the people who do the front end, who do the query, the power to fetch all the data they need. Let me quickly check on. Oh, there's a couple of questions, but we're gonna answer them later. Awesome. Cool. So let's move on. And then you can see here's the person. And here's another resolver. What you can do is, in this case, it could even be, because if you don't, you always get passed in the parent. So for example, if I'm here, I fetched the person by the ID. In the person, I actually get that object, which is here as parent. And then you can even rewrite attributes, which comes in really, really handy, because let's say if your API only provides you with let's say full name, but you actually want to expose name to the client, then so this is kind of this is absolutely not necessary. If there would be parent.full name, then it would make sense, but this is probably not the best example here. What you also can see is like GraphQL null type, so there has to be a name for a person, and you can define this. Yeah, so far so good. Cool. So previously I told you about introspection. So what happens is, if you define the schema, and because it's typed, you can actually, with every GraphQL endpoint by default, you can actually introspect how the types look like. And this is pretty cool, because this allows us to do this kind of auto-completion in GraphQL. So if you see here, let me copy that over again. So what you can see here is, because every GraphQL schema basically exposes its own schema as a GraphQL queryable schema. So what happens here is, if we have defined this type person, you can see things like, let's make it simpler first. You can see like the name of that type person is person, which is more or less pretty obvious. But you can do things like a description. If a description in the GraphQL schema was defined, this is really, really useful for somebody who's external and start to use your API to actually tell them like, what is it about? What is this field about? But then you can also go into, let's remove the name and description. You can do things like get the fields. So you can figure out like, this person has all these fields, and this is how we make this happen with control space again. Remember that you can actually autocomplete on what's there, and I can say height. Oh, wait a second. So because I have the name, I can do this, but if we, let's go back here, let's do, so now I know I fetch this data and I see skin colors here. So if we fetch a person, and I think it was ID is 1, and you can see that's why GraphQL can this auto-completion. So by having a type system, I made a mistake here. Let me quickly check. How was the ID fetched? Person ID. Okay. Oh, because so it's person ID. That is one. They basically have two IDs. Don't ask me why. Might be interesting to see here. People 1 is, oh, we enhanced the ID. Okay. Don't worry about that. In reality, you probably only have one ID. This is also specific to Relay. Yeah, not too. Don't worry too much about it. But what basically happens is like it encodes the ID for that Relay needs that to build up an automatic caching layer in the front end. But the real ID is 1 that you can see from the Swappy API. Yeah. All right. So far so good. So the great part about this typed schema is that you suddenly get to a point where you can build really great tooling because of the fact that you have this typed schema. All right. And I think that brings us close to an end with GraphQL, the introduction. There's one more thing I wanna show you is that you can take this and you can even build fragments. Okay, there's a mistake in the. What if I do it here? So, what? This is interesting. Oh, yeah, of course, I need to have this variable. Does this work? Can I use the query variables? Yes. So what you can see here is we can even build fragments. So we can. This comes in super handy if you reuse certain data in your application more and more. Then you can say like I want to build a fragment of a GraphQL query, and you can use this to reuse stuff, and you don't have to write out all the queries all the time. So this is another handy feature of GraphQL. But this is probably getting more into an advanced usage of GraphQL. All right, so far so good. So let's move on to the serverless part. So what I'm gonna do is I'm gonna focus more on serverless the architecture rather than the framework, because there are a lot of things that are serverless. So there's like this idea of a serverless architecture. There's nowadays the serverless conference. There's the serverless framework built by the Serverless Inc., which I'm part of. And since recently, there's also like from Amazon the serverless application model. But I want to start out with the serverless architecture and what this means and what means serverless. And to start out, I want to quote Mike Roberts here. So he said he made a guest post on Martin Fowler's blog. Definitely a good place to learn deeper about technologies and concepts. And so Mike Roberts made this post, and he said, serverless architectures refer to applications that significantly depend on third-party services, known as backend as a service, PaaS, or in custom code that's run in ephemeral containers. And That's what we call function as a service, or FaaS. And the best known vendor host of which currently is AWS Lambda. And by using these, and then he goes into all the benefits, but there's two important parts here. For once, there is this part where we have backend as a service, and then we have the second part where it's function as a service. And this is, you probably heard of, you might have heard of AWS Lambda or Google Cloud Functions or Microsoft or the Azure Functions. And there's many, many more, like Iron.io, for example. There's a lot of services nowadays that allow you basically to, like, you just write your code, you deploy, and then everything is up and running, and they scale for you. And this is really, really great, because suddenly, like, I mean, these functions are, you can't have state. But what's interesting here is that you just ship your code and it's up and running. When we look at the whole serverless architecture, like just having functions that do certain things, this doesn't allow you to build large applications or actually something useful. You need state, you need to store data somewhere, and this is where this backend as a service concept comes in. So for me, serverless means not only this concept of this ephemeral containers that actually just run and work out of the box, but it also means like having a whole environment of services that you just configure. So you don't really you don't run them. You don't run your database by yourself. You can obviously, but the whole serverless idea is that you don't have to maintain any servers. It's not about like having not the server, but it's just like you just deploy and you don't have to maintain them. You outsource that work to an infrastructure provider. And yeah, so this is for me serverless. These two concepts. What I want to go a little bit into, because we need it more for combining GraphQL with serverless, is the second part, the FaaS part. And what's happening here is that with this concept, the function as a unit is becoming the unit of application logic. So we don't break things down anymore to whole servers that do certain things, and we have just single functions, and they do work. And what happens is, or what you do is, like, basically you deploy code and they spin up, so these providers spin up instances whenever you need it. So if you have 0 requests, the function won't have an instance, but as soon as the first request comes in, it's like they spin up a server and they execute your function, and then they return the value if you need it, or it will be async. But it's a concept that also scales really, really well, because you just give them a code, and if you have 1 million requests from in a minute, because you run a marketing campaign, it will scale, and that's the great part about it. These functions, you can connect these. I told you already, we have this backend as a service, so you can connect these to different services with Amazon, and then these services fire events that can actually trigger your functions, because you need basically these functions become the glue between all these backend services that you just configure, and it's your glue to build an application. And they're triggered by events then. So for example, if you upload a file to a file storage for Amazon, it would be S3, then an event is triggered, and that event, you can subscribe to these events for a specific function and do things. Let's say somebody uploads an image, you can, if the image is uploaded and a new file event is triggered in S3, you can subscribe to that with a function, and you can resize the image and create 3 new thumbnails that you use for your application. And how all these services work as of now, at least the ones that I know, is they're somewhat stateless. So what it means is you have no guarantee when and you can't actually figure out like when instances are spin up and when not. You should design your application in a stateless way, your code, because there's no guarantee that you have no control over the instances. You can't SSH into them. You can't control when they are spin up, when they are shut down. That means like if you have something running, if you deployed code to your Lambda, you cannot say like at what point this instance will die off. And that's why you need to work in a stateless way or write your code in a stateless way. I mentioned here, I made a remark, it's only somewhat the case, because what's happening is it's not like on every new request they spin up a complete new instance. What they do is basically they freeze the process, so you can't do there's like no work that you can do after it's done. But you can store something in memory that you can look up in a later request. So you can use this for caching, for example. But yeah, isn't that somewhat limiting? Absolutely, yes, it is. Nevertheless, what I want to do is, like, from my past experience, I don't want to maintain these servers. I don't want to fiddle with the infrastructure, because I mean I would see myself more as a product engineer. So I want to build things that actually provide value. And I think I mean it's sometimes fun to fiddle with all the infrastructure. I kind of enjoy it every time I do it. But when things go down, and we know the failure from Twitter, then it becomes really stressful, and you lose a day or two. And I think this is there are people like Amazon, Google, Microsoft. They're really good at keeping your infrastructure alive and keep it up and running and in a performant way. So I rather outsource that to them. And I think this is also like my personal motivation. Why I joined the serverless company, because I think this is the future. More and more people are gonna actually want to focus on building products and let somebody else do this. And so this is, if you look at it from a historical perspective, that's how I try to explain the term serverless more and more. Is like, basically in the past we had these machines, you had to actually go there, sign a contract, or call somebody if you want to reboot it. Then we got the cloud, we got virtualizations, you just hit the head of a button and you spin up a server. We got containers, which now you spin up a whole cluster of servers. But in the end, you always maintain them. If things like Heartbleed come along, you have to actually go in and like make sure you have the latest version of OpenSSL, and it's your responsibility. And that's what I like about serverless, because basically if there's no request, nothing is happening. If a request is coming in, they spin up the instances. They know exactly how many they need to spin up. They do this work. And if there's like more, they need more, and they shut them down if they are not needed. And they can also, like, if they have to do an important security fix, I mean, they can just spin up all the instances and really spin up new ones and deploy these bug fixes. And yeah. So what are the benefits? Obviously, auto-scaling. So you just deploy, and the lambdas by themselves will work out of the box. And if you use this backend services and don't maintain your own database, then most of them they auto-scale pretty well. You have pay-per execution, which is really nice, because you don't pay for instances that are up and running. You only pay what you actually execute. And that's pretty cool, because like we've seen this from customers and framework users. Like, it significantly reduced the cost for them, and it's event driven. for me personally, that's a benefit, because we get to more this event-driven model and reactive systems, and then I think that's the future. And you still can build all the common use cases. People build web applications, mobile IoT backends, people do a lot of data processing, people build chatbots. So you can do all sorts of things. There's one limitation. Most of these providers currently limit the maximum time a Lambda can run. So I think for Amazon right now it's 5 minutes. That might change in the future. But that's a limitation. So if you have something like a really long running process that you can't split up into multiple tasks, then this is certainly a limitation and you might want to use something else. There's a ton of providers. Oh yeah, I totally forgot OpenWhisk in the Auth0 web tasks, so you can use them as well. IBM OpenWhisk, they have a really great offering, so it's pretty amazing if they build. Yeah, some hard numbers. That was presented at reInvent in 2016, late 2016. So Thomson Reuters, for example, processes 4,000 requests per second. And I mean, there's no special DevOps team that that needs to maintain these lambdas. You just have the code you deployed and it works. You have to pay for it. That's probably not super cheap by the amount they run, but it's as Lambda is AWS Lambda pricing. It's super cheap. Oh, there we have it. So if you look at it, price per, you get charged by like 100 milliseconds that you do, and you need to do a lot of requests to actually get $1, and you need to run a lot of work to pay for it. And they always they have a free tier as well. Yeah, you can actually, if you have a lot of like super tiny microservices, you can use the free. You can basically get a nice service for you up and running for free. A lot of hobby projects run nowadays on AWS Lambda, pay nothing, but there's like a friend of mine built himself a reminder that he has to move his car whenever the street cleaning comes on Tuesdays and Thursdays. So he gets he connected, he used Twilio with AWS Lambda. It's a scheduled Lambda that every Tuesday and Thursday sends him a message as a reminder to move the car. Yeah, and there's FINRA runs stock validations on a daily basis. Vivo showed that they can handle like 80 times the normal traffic, and this is quite impressive because otherwise if you want to provision for that, you pay a lot of money for a lot of servers that have to spin up really, really quickly. Or yeah, it's like if you want to deal with spikes, you basically need to be over provisioned all the time. And with Lambda, you get all of that out for free. There's a lot of challenges that it comes with. You have monitoring changes. Because it's still very early, there's like a lot of these things that we have to fix first because the concept changed. But yeah, there's a lot of good people working on these challenges and making it easier and nicer to use serverless architectures. A little bit about the serverless framework, why it's actually there. There's a couple of, I'm going to focus on AWS here, but you can deploy Lambda via the UI in AWS in the console. You can do it via an API call, or you can do it via CloudFormation. The thing about the API call, this is only part of it, because creating a Lambda is the easy part. What you then need to do is you need to attach permissions. You need to attach the event and tell us S3 basically, hey, I want to listen. This Lambda should listen to this event, and you end up with a couple of calls doing that. And there's also this tool from AWS which is called CloudFormation, and you purposely cannot read this because this is if you have a CloudFormation file with an HTTP endpoint, this is basically what you need to do to get everything up and running. It's a lot. The UX is not there yet. And recently they announced the serverless application model that makes it a bit easier. But there's still you have to write a bit more code. I mean, the serverless application model is pretty great. But this is where the serverless framework came in, and it's widely used. That's a little bit of self-promotion here. But basically, it allows you to have a very concise syntax. You create the service, you lock the framework version. You don't have to, but I highly recommend this. And then you say hey, these are my functions, these are my Lambda functions. So for example, here would have get current time, and then I can attach an event, and this is all you need to do. And in fact, what this compiles to is exactly what you have seen here. And this is all the things, it's all the best practices, everything that you need to have a pretty good setup for an HTTP endpoint. And yeah, and then the code looks pretty simple. So in this case, I would simply have a handler.js file. You can see here's my handler, and then I have this one function that I export, which is the endpoint. And then you get a signature, which is the event, the context, and the callback. And in this case, we would just return a response with a body. And why we built the serverless framework is initially to simplify all the process, but the benefit is also it is a full system to deal with these applications, because you can deploy it. But what you can do is you can get the logs out by running serverless logs. You can invoke a function locally. In this case, I'm basically just deployed this endpoint that I just showed you, and to get out the current time. And yeah, but it's it comes with a set of commands that are really, really useful. So there's also serverless invoke local, so you can run your code locally and test it before you actually get to the point where you deploy it online. And if you're struggling with getting started, there's there's github.com serverless/examples, and we have a ton of examples there that should help you out to build your use case. So let's dig into the last part. So why do our serverless architectures and GraphQL such a great combination? Because what you can actually do is, I already mentioned, we have this idea of GraphQL being the layer. GraphQL is the layer between your front end and your back end. And what you can do then is you basically can build one Lambda that exactly is your GraphQL endpoint. And this is really, really nice, because what you do is you basically have you use configure API gateway, which is the service from AWS. So I'm going to focus again here on AWS, but you can do this with Microsoft, IBM, Google as well. But you basically define your HTTP endpoint via API gateway, and then you get a JSON event to your Lambda. And this JSON event is all the data. It is basically then your GraphQL query is part in there, and then you can build with your Lambda your GraphQL endpoint, and you can use any kind of data storage or to get the data out. And this is what we do internally, and this is the concept that I really, really like, because the GraphQL endpoint in this case and in general is like, it's stateless. It's just there to fetch the data, to like basically spin out and get from like your internal environment all the data that you need. And this becomes like this one, if you have an application, it becomes your one entry point to your whole application. And this is also this is really, really neat to manage then, because you have one endpoint, and this is this endpoint is like everyone who is building a front-end or mobile application for your the front-end or mobile part, they know I need to talk only to this one endpoint, and everything from on there is managed by the backend. But obviously you can replace the data storage. So in this case, I could a query could result in multiple fetches from DynamoDB, but I could do the same thing with Postgres. It doesn't have to be one specific one. And what we actually do, and what I really enjoy, is we basically built this this kind of microservices or almost like nano services. Like we have a couple of Lambda functions that do certain things and make it very specific to fetch data. And then what happens is like we have this one GraphQL endpoint that reaches out to these different microservices, which is a and I mean, in this case, then the microservices are always like one to maybe a handful of lambdas, and they do very specific things. And then you fan out to these services, and you don't even necessarily talk right away to the database, and you fetch the data that you need. And in our case, even like the front-end teams owns the GraphQL endpoint, which comes in really handy, because then you can move really, really fast. You can adopt your schema, you can right away take it to the endpoint, but it's still safe because these microservices handle authentication and authorization. And it's a so from my experience, this works really, really well, and you can iterate quickly. Let's go into a hands-on example, like how would it actually look like. So let's define here, in this case, I'm running a meetup Vienna, which is called React Vienna. And like if we build a page for that, we can say like, okay, we define our GraphQL schema, we have a name and we have a description. And there I have my root query, which I put into schema.js, and I basically get here's my meetup type that I defined, and here I'm making a list of this meetup type if I want to fetch all the meetups. And then in my Lambda, what I can do is, so if you look here, I say endpoints get meetups. So if I want to build this, there you can see the resolve function. So this is then, I would build another Lambda. It's exactly this concept that just fetches the meetups. And it does one specific thing, and it has this power to do that. And this is how the code for it would look like. So you'd have GraphQL. Oh, sorry, that's the GraphQL. And then it fetches these. I show you that in a bit how it looks like. But basically, what we have then here is our handler, which is our GraphQL endpoint, and it's really, really simple because you get the event, which is coming through API gateway, and part of the body is the query and the variables, and you just pipe this through GraphQL. You just get from the schema that we defined. There's one part missing, but you basically just execute GraphQL with the schema, and you handle the query, you get back the result. And this is a very simple endpoint, but that's all you need, because all the resolving functions, like how you resolve this the specific queries, they are part of your schema. And as a reminder, there's still this other way of doing it. You might want to try this first, but yeah, that's what it is. And if you look at it, So in this case, I built a small service to actually fetch these to have a site on endpoint for my meetup page. And what you can see here is then it deploys to a GraphQL endpoint. This is the endpoint that I created with exactly the schema. And what I can do then is define the root query meetups, and then we can fetch the name. And so what we can do is we can fetch the names of these specific meetups, but we can again only fetch the data that we really need. So how do I get the data that I haven't showed yet? Is in this case I'm using get meetups. What you have seen before is this endpoints.get meetup. I actually wrap a REST API, and if you're coming from a front-end perspective, this is probably a really good way of introducing GraphQL with your team. You just take your existing REST endpoints and you wrap it with one Lambda that has GraphQL and that knows how to fetch all your data, and you build up the schema with like wrapping your REST endpoints. The benefit of here is that you don't change anything in the backend. It's not a big restructuring, refactoring. It's like it's just like taking what you have, you put a Lambda with a GraphQL endpoint on top of it, and suddenly you have GraphQL for your team available, and it has only like a super small overhead if you're already living in the same, because you do this one additional request, or like you have to pipe it through the Lambda instead of going directly. But the benefit is that you get this really nice interface, and if that works for you, then you can actually start optimizing and replace HTTP endpoints to directly connecting to a database, or going through other Lambdas, or going through internal microservices. And in fact, this is exactly what GitHub did. So GitHub, I mean, not they used their they used another server that manages GraphQL, but it's basically the same concept. What they started out with is they were experimenting with GraphQL. They wanted to see if like GraphQL is an option for them. So what they built is like they built this GraphQL endpoint that just connected to the internal to the HTTP endpoints and wrapped the initial API. And once they saw like, hey, this actually lets us move way faster, and this makes sense, then slowly they started to connect directly to microservices and get that information rather than talking directly to the public API with the HTTP endpoints. And this is where I think the love story comes in, because it's so amazing how you can start out. I mean, as someone who's right now responsible of the front end, that's probably everywhere where I would go, I would and there was an existing REST API, I would introduce this concept, because you can move so much faster on the front end. You can develop so much faster, and it's also the same way, because you have this one connecting point to all your internal microservices, and you don't need to think about like, do you need to talk to this API? How do you need to structure the APIs? Are these multiple URLs? It's like one endpoint that you talk to. And the great part is also that if you use it with Lambda, I mean, it's theoretically indefinitely scalable, theoretically infinitely. It's just about like how much money do you put into AWS that will define like how much money you can pay. That's your limit. AWS can scale out like crazy, or Google and Microsoft, and so you have this one endpoint. So it's also a very good story of for an existing backend team, because somebody can put the Lambda there, and it's a zero maintenance issue. It's up, it will run, it will not go down. And if it goes down, then you have a problem. But these these events are very, very rare because AWS, Google, Microsoft, IBM do a good job there. And so we actually, like in this case, I just fetched the information from the API, and then basically JSONified the response, and this is exactly what we use then in our schema to resolve all the existing meetups. And what you can see is, like, if you look at this endpoint, gives you all sorts of data, and you can and GraphQL filters out all the unnecessary part by itself. And this is also great because you only ship what's really relevant. If you really want to optimize what you in this when you resolve the function, if you go back here in the resolver, you actually get arguments, and you see like what data is requested, and then you can actually fetch exactly what you need. So you can optimize your SQL queries based on your based on the attributes that are requested by your GraphQL query. Yeah, so how to get started? What we did is there are two for the web. There are two popular clients. First one is Relay. Second one is Apollo. Relay is from Facebook. They built it originally. They're currently working on a version 2, which will look quite different. So what we did is we recently looked at both of these projects, and we decided to go for Apollo, and I can highly recommend it. It's amazing to work with it. And what but basically we had a relay setup before. So what we did is we extracted this relay setup into a public repository that you can use as a starting point. And the relay version, to be honest, is a little bit out of date. So you might have a couple of outdated packages that you want to upgrade, but it gives you a really great starting point of like to see a full setup that works out of the box on Lambda. We have a serverless GraphQL Apollo starter kit or boilerplate that you can see and that we actually maintain because we have the same, using the same right now internally, and you can use this to get up and running with a GraphQL Lambda endpoint, including a front end, within minutes. So you have you take this thing, you deploy it once. Right now you have to get the API endpoint, and then you can basically build your website with Webpack. It's also part of it, and you can soon be going to migrate to React Creative, so it becomes even easier to use the front end. But basically, then you upload your front-end application to S3, and you have a full application backend, so like front-end, including a GraphQL endpoint out of the box, and this can be done in minutes. That's pretty cool, and it's production ready because it's Lambda and it scales, and that's I find this really exciting. Yeah. And so if you have any questions, just send us a message, or happy to help you with issues there. And yeah, but that's basically an easy way to get up and running in this combination like serverless and GraphQL, either with Apollo or Relay. Yeah, and I think now we are at the questions time. So there have been 2 questions so far. So I look into, I read them out. And so how do I add the request model for a post endpoint so that it appears in the API gateway when I then export the API for iOS? Wait a second, let me rewind. a request model for a post endpoint so that it appears in the API gateway, then export the API for you. I haven't used either iOS yet. I mean, what I can show you is, so maybe I walk you a second through the API endpoint here. So what you can see is with the serverless YAML, you have the handler here, and the handler is this GraphQL endpoint, and then we have this HTTP endpoint, and this configures API gateway. So API gateway, as I already mentioned, is a server from AWS, and it has this HTTP endpoint with the path GraphQL, and then we say it's method post. In this case, I also enabled CORS. That depends on like how your setup looks like. I use integration Lambda. There's a PR to switch to Lambda proxy. We will merge this soon. But this is basically how you configure your function endpoint. And then you can see here we simply have our handler.js, and in this case I just get from GraphQL the index, and then pipe the query and the variables through and make a response. And what you can see here is GraphQL. I have this in a separate folder, but basically this builds up your whole schema. So you run GraphQL with your schema, your query, and then all the necessary variables. And your schema is like how you basically build up your schema. You have a query type. In this case, we have no mutation. But yeah, and then it goes into types. You could have the user type, which then has a field of ID and name and so on and so forth. I hope that answers your questions. If not, just let me know. Persistent instances EC2 have no trouble maintaining connection to a database, enabling query lookups that are very quick and performed. How do you address the latency cost incurred when each resolver modeled by Lambda springs into existence and has to create a new connection to the DB each time? That's a good question. To be honest, I don't know, because I'm connecting to, so right now I'm basically in charge of the GraphQL layer and the front end, and we have internal microservices that deal with them. Some of them, like almost all of them, use Lambda. Some of them they don't. So I would say that's I can't answer this issue, but what you can do is you can send me a message, and I try to forward you to one of our backend guys, and they hopefully can answer this question. I don't know too much about it. Can we see an example of how GraphQL connects to a database endpoint? I don't have an public example right now. Yeah, because also also in our internal app we connect to microservices or lambdas, part of various microservices. So I actually don't have. You basically would write it in the resolver function. So if you look at this one here, in this case there, let me go here. So if you look at the meetup example, like here you can write any JavaScript code, and obviously this works in Ruby and Scala and so whatnot as well. But here you could write any code you want to fetch data. Here you could actually have the code to connect to your DynamoDB. And if we go to examples, serverless examples, Git hub.com/service. So if you go here and you want to see, for example, at the DynamoDB example, you could say here the to-dos. So let's take a get. So to fetch data from DynamoDB, you simply use the AWS SDK, instantiate a DynamoDB instance, and then you can fetch directly from DynamoDB. And so what you could do is you could move this to a separate file, or you could have it in your GraphQL schema directly, or you create another lambda that exactly does this specific work, and then you just invoke this lambda and fetch the data. And I'm not sure if we have, there's other services like FaunaDB. I'm not sure if we have a Fauna example in there yet. Or Google recently announced Spanner, and so you could basically how the code looks like to fetch data. It's just in a resolver function. You can do anything you want to retrieve data. So you can get to DynamoDB, HTTP, whatnot. Yeah, and if there are no more questions, I think then we're done. And
yeah, Nick, I have a question for you.
Thank you very much. Sure, go ahead.
Is there any project you're working on at the moment that you'd like to mention? Is that like a sneak preview or on something cool you're going to?
Sure. So I'm pretty excited about a language, a new language called Reason. So this is like fun stuff that I do on the weekends. Reason and ML is a new syntax for OCaml. Wait a second, let me find it here. It's a new project by Facebook, which is uses OCaml under the hood. So it basically took out the top layer, the syntax layer of OCaml, and replaced it with what they call Reason. And it's a super new, interesting language because it has immutable. It has immutability built in. It's very functional, and they even allow syntax like JSX. So what you can do is, and it compiles to binaries. So you can build a binary for OS X, Linux, Windows, or you can build, you can compile to JavaScript. And I think if this turns out to be like, I'm pretty optimistic. If turns out this works, this is really awesome, because then eventually in the future we can use one language to write really efficient code that we can compile to a binary, and like, for example, like Go does. It's super fast, but you also can compile to JavaScript, and then you can use React to do server-side rendering, but on the other hand, like have microservices that are written in the same language and have the safety of a typed functional language, and be as fast as Go, if not even faster. I think there's some performance comparisons via OCaml compiler and Go, and in some cases OCaml even outperforms it. I don't know. I'm not 100% sure about this. I just heard some things the last couple of weeks, but I still have to read up on that myself. But yeah, this is so what a couple of friends of mine from Vienna and I started to work on. So it's Patrick, Carl, Oscar, and me. We started to build a serverless Reason plugin and we have this endpoint up and running, where you basically, let me find the code. It's just a hello world right now. So you can send to this endpoint a query parameter name, and it will give you back a response with hello and then your name, which was just there to prove that we actually can make it work, and we run it on Lambda. So that's what I'm pretty excited about. This is really cool. So reason is something I'm currently looking into, and it helps me to stretch my mind a bit, like go with functional, go immutable, go typed. As someone who's coming from JavaScript, it's a really interesting approach.
Is there anything you'd like to suggest to anyone out there who wants to start using serverless and the serverless framework?
Yeah, I mean I think best start is like set up an AWS. Oh, you could do serverless. Let me. So like 2 months ago, I started to record a session on how to get started with serverless, and I think it's not more than 7 minutes or so. It's basically like how to set up your AWS account with your credentials, how to deploy your first Lambda function, and then attach your first HTTP endpoint, and you are up and running. And this is it's less than 7 minutes or 8 minutes, and yeah, this is probably the easiest way to get started, and from there on, I highly recommend to look at our examples folder. There you can see all sorts of use cases. We have Alexa skills, we have the IoT event support. You can do GitHub webhook listeners, Twilio, send text messages, like basically all out of the box there for you to build your application and with example code. And for example, how to build a REST API. You're gonna see like an example of like how to actually run this and test this, and there's all the code to look at and basically copy and reuse that. Yeah, and that's it.
Wow, that's amazing, Nick. Thank you.
Cool.
Yeah, I think that that's all for today. If you, oh yeah, something that I'd like to mention also, at Cloud Academy, we launched a few weeks ago a new learning path on serverless. So have a look, it's really well done. And it might help you guys to approach serverless and serverless framework in a very good way, as Nick just mentioned. If you missed some of our previous sessions, live session, you can find everything on our webinars library at cloudacademy.com/webinars. And as mentioned at the very beginning, if you have additional questions, there's also our community at cloudacademy.com/community. We'll try to answer all the questions that we're not being able to answer today or in previous sessions. So have a look. And thank you very much, Nick. It's been really good.
It was a pleasure. Awesome.
Absolutely.
Cool. Then thank you for listening, guys. Awesome.
Absolutely. So thank you, guys. Keep an eye on us on new live session and keep building amazing things on the cloud. Until next time. Bye for now. Bye, Nick.
Bye-bye. Have a good one.
Bye-bye.